Hi, my name is Jennifer Strang from the GIS Center at the Dalhousie University Libraries. This is going to be quickish tips on how to create realistic trees in ArcGIS Pro. In the example today, we're going to use a subset of the public tree data supplied by Halifax Open Data around the Dalhousie University Studley campus. The data contained in this open data is the location of the trees as well as the tree type. It does not contain the height, so we're going to estimate that using the DEM and the DSM generated from LiDAR data. Note that this will require the Spatial Analyst extension. We're going to begin by creating a new map project. We're going to do this to keep all of our data organized. So when we create the project, it's going to create a project folder. And inside this project folder is where we're going to keep all of our data. So you're going to start ArcGIS Pro. You're going to go to the New Project and Map button. I'm going to suggest calling it Halifax Trees and putting it in a location that you're aware of. We're going to start by making a new ArcGIS Pro map project. So you can see I've started ArcGIS Pro. We're going to go to the New Project, Map. It's going to ask us the name of our project. I'm suggesting you call it Halifax Trees. And the location, it's up to you where you put it, just so long as it's in a known location. So for me, I'm going to put it in my C drive in a demo folder for now. Okay, and then you're going to click the OK button. And an empty project will open. When the project opens, note that this has created a project folder by default, and this is where we're going to put all of our data for this project. Next, we want to download the tree data. Go to the HRM Open Data site. You can simply do a search on HRM Open Data and go to the catalog. Or you can type in https://data-hrm.hub.arcgis.com/pages/open-data-catalog. When the page opens, go to All Datasets and search for Public Trees. I'd like you to download the file geodatabase version of this data and then unzip the data into the Halifax Trees project folder. Next, we're going to download the tree data. We're going to go to our browser of choice, and then you're going to type in the address I gave you, or you can simply do HRM Open Data and look for the Open Data Catalog. It'll take a moment or two, but when you get here, you're going to go to All Datasets, and you're going to search for Public Trees. Okay, and there it is, the feature service. It'll take a moment or two. You're going to go to the download option over here on the left-hand side, and you're going to choose the file geodatabase option. It'll take a few moments to load. You can see there's over 69,000 records, and you can see it's downloading up here in the upper corner. So it appears to be done. So I'm going to go down, take that data, and extract it into my projects folder. So here I am in my downloads. There's my public tree data. I'm going to right-click on it. I'm going to say Extract All, and then I'm going to put it in my folder, my project folder that was created, which is in my demo folder. Okay, and then I'm going to click the Extract button, and the data will extract from there. Now that we've downloaded the tree data, we need to add it to our map. To do this, go to the Map tab, Add Data button. Then you're going to find and select the public trees that we downloaded. We want to check out the attribute data that comes with this data. To do this, you're going to right-click on Public Trees in the Contents panel on the left side. choose the attribute table option in the pop-up. Take a look at the attributes that are available. One thing to notice that HRM uses codes and domains for both the scientific and the common names of the trees. We're going to deal with this a little bit later. What you're seeing is actually the domain name and not the actual value that's stored. Now we're going to add the tree data. We're going to make sure we're on the Map tab and Add Data. Then we're going to go into our folders under Halifax Trees. You'll notice that there's two geodatabases, the halifaxtrees.gdb, which was created when we made our project, as well as the one that we extracted from the data that we downloaded. So that's the one we're going to add, and we're going to click on Public Trees and choose OK. The map will zoom in to the area where the trees are and display them all. What I'd like you to do is check out the attributes that are associated with these public trees. To do that, you're going to right-click on Public Trees. You're going to choose Attribute Table. You'll notice that it appears at the bottom of the screen. You're going to see what sort of data is available here. So you can see there's asset number and tree ID and some codes, the year it was planted, and how much confidence they have in it. And a couple of ones of particular interest are the scientific name and common name. You also have information about the diameter at breast height and the unit, as well as confidence, the general location of where it is, as well as when it was added. The catch with this is, although that we can see the scientific and the common names here, it's actually recorded as a domain. So this means there's a code that's in here instead of what we're seeing, which is the domain name. So we need a field that contains an actual name and not a code. So we're going to deal with this momentarily. We're going to make a much smaller data set than the nearly 70,000 records that we downloaded. So zoom in to Studley Campus. Once there, go to the Map tab, use the Select button, and draw a box or a polygon around the area of interest. When you've selected the points, the trees will turn cyan in color. Then right-click on Public Trees in the Contents panel on the left side. It's going to bring up a pop-up. Choose Data, Export Features, and name the output feature class as Studley Trees. Then remove the original Public Trees file from the contents by right-clicking on it in the Contents panel and choosing the Remove option. So we don't want to deal with a file that has nearly 70,000 records in it, so we're going to make a much smaller subset. So I'm going to close this out temporarily. We're going to zoom in to Studley Campus, so I'm just using my mouse, my center roller button, and here is Studley Campus approximately. So I'm going to go to my Map tab up here. I'm going to use the Select button, and I'm going to choose Polygon. Okay. Only because it's at a bit of an odd shape. So I'm going to draw my polygon approximately around Studley Campus. I'm going to double click to end it. And you can see these trees have highlighted in cyan. So I'm going to extract those out to a new layer. To do this, I'm going to right click on Public Trees, and I'm going to go down to the Data option, Export Features. Okay, so you can see based on this, it's giving me a bit of a warning. Your input has a selection. Records to be processed, in my case, is going to be 741. Yours will likely be different because chances of you selecting the exact area mine is slim. But it's only going to work on these selected records. So I'm suggesting that you call this data Studley Trees. So you can see that I've deleted that whole line because by default it's automatically going to put it in my project geodatabase. So you can see I'm calling it Studley Trees. I click OK, and it'll take a moment, and you'll see this new file appears in my table of contents. So I can actually now remove this Public Trees dataset from my contents. I right-click on it and choose Remove, and you can see I now just have those selected points. And the thing about removing the data, it doesn't actually delete the data, it just takes it out of the project and keeps it a little bit clean so I don't get too confused on what's going on in my contents panel over here. What is a domain? An attribute domain in a geodatabase is a mechanism for enforcing data integrity. Attribute domains define what values are allowed in a field, in a feature class, or other non-spatial attribute table. So this is important to us because the public trees data uses domains within their geodatabase. So they're actually storing codes for both their common and their scientific tree names instead of the actual name. So we need to have the actual name of the tree for us to do some calculations a little bit later on. So using codes with domains in files can enforce data integrity, and it can also make the data smaller, but it can also make it more difficult to use in some cases. So what we're going to do is we're going to create a field that contains the actual tree types instead of the code. So to do this, we need to create a table from the domain that it currently exists. Go to the Analysis tab, Tools button, and look for the Domain to Table tool. When the tool opens, for the input workspace, use halifaxtrees.gdb. For the domain name, use the selector and choose the AST_tree_sp_com. Okay, so that's the domain that's currently being used. For the output table, we're going to create something called common tree types. The code field, we're going to put code in there. And for the field description, you're going to enter common tree type with no spaces. So now we're going to make a table from the domain. So to do this, we're going to go up here to the Analysis tab and the Tools button. We're going to search for domain to table. Okay, there's the tool. We're going to click on it. So the input workspace, we're going to make it the workspace for our project. So again, I'm going to go into our folders, our Halifax trees, and we're going to use our halifaxtrees.gdb. Okay, so we're just going to do a single click and choose OK. For the domain name, we're going to use the drop down and pick this AST_tree_sp_com. For the output table that we're going to create, we're going to call it common tree types. Okay, for the code field, we're going to call it code. So there's going to be two fields in this, one called code and one called common tree type. Okay, and then we're going to hit the run button. And you can see when it finishes, it creates a standalone table. You're welcome to open it up, right click and open. And you can see here are the codes that were stored in the domain, and this is what the actual name that was displayed within the description of the domain. So now that we have a table, we want to join it back to our Studley trees. To do this, you're going to go to the Analysis tab, Tools button again. In the Geoprocessing panel, you're going to type Join Field. You're going to select the Join Field Data Management Tools. The tool itself, for the input table, you're going to enter Studley trees. For the input join field, it will be common name. The join table will be common tree types. The join table field will be code. And the transfer fields, the one that we want to see in our new file, will be common tree type. Now we're ready to join our table back to our Studley trees. So in order to do that, we need to use the Join Field tool. So you can either access it by going to Analysis Tools and typing the name, or in our case, because we still have the geoprocessing window open, we can just use the back button. We're going to look for the Join Field tool. Okay, and there's the one we want, the data management. The input table that we want to join things to is going to be Studley trees. The input join field is the coded name that we are going to be using. In our case, we're going to be using common name. The table we want to join is this one we just created. So that is the common tree types. And the name of the field, you can see, is going to be called code. Okay. The select transfer fields, what is the one we want to have in our original Studley trees file, is going to be this common tree type. So that's what I'm going to select. Okay, then I'm going to hit the run button. And if I open the Studley trees, the attribute table, you'll notice at the very end of this, I now have a common tree type that is not a domain. So this is really important because we'll be using this a little bit later. Next, we need to add elevation to the trees. In order for the trees to show realistically, we need to have a height value. Looking at the attributes, there currently isn't one. Okay, so we don't have to worry about this if you have a fine resolution DEM and DSM, because you can calculate it. So remember, a DSM is a digital surface model and incorporates the height of buildings, trees, cars, etc., while the DEM is the digital elevation model and is considered bare earth. So the height of things would be the difference between the DSM minus the DEM, and then you get the building of the height of your tree or your building or your car. Next, we're going to get the DEM and the DSM data for Studley campus. So you're going to go to https://nsgi.novascotia.ca/datalocator/elevation, or simply search Nova Scotia Elevation Locator. When you get to the web page, turn off all of the items in the LiDAR index except for the 10K derived products. Then zoom in to the Studley campus where you downloaded your trees. Click on the Select by Polygon button, and then click the Select Features button and choose the correct box. Then go to the Selection Results tab and click on the Add to Download for the most recent DEM and DSM. Then go to the Downloads tab and download those two files. Now we're going to get the DSM and the DEM for Studley campus. So we're going to go again to our browser of choice. I'm going to open a new tab and we're going to search for Nova Scotia Elevation Locator. Okay, and you can see we're going to use this first link that pops up. So this is the Province of Nova Scotia Data Locator. So this is a great place to get all kinds of elevation data from the province, particularly the very detailed data. So we're going to go to the LiDAR index and turn off everything except for the 10K derived products, because the 10K derived products is what we're going to be looking for. So that's all these little blue boxes that you can download. So what we're going to do is we're going to now zoom in to our area that contains the Studley campus, which is the southern part of the Peninsula Halifax. And now we're going to go to the Select by Polygon button up here. And when you do that, you'll notice a new tool opens up. We're going to click on this first button here, which is Select Feature, and we're going to select the box that we're interested in. Okay, so you can see it pops up with a bunch of information about it as well. Next, we're going to go to the Selection Results tab, and you can see this is all the data that occurs within this box. So I suggested you want to download the DEM and the DSM, the most recent data. So that's 2019. So I'm going to click on the Downloads file for both the DEM and the DSM. Okay, and next I'm going to move over to the Downloads tab. You can see here are the two files that I want to download. So I'm going to click on the Download page or button, and I'm going to get those two files to download. They are quite large, so it may take a few minutes for this to finish. Next, we're going to need to unzip and extract both the DEM and the DSM into the project folder. Once they're extracted, you're going to add them to your project by going to the Map tab and Add a Data button. Next, we need to calculate the height model. So you're going to go to your Analysis tab, the Tools button, And in the search, you're going to type raster calculator. You're going to choose the raster calculator Spatial Analyst tools. This is going to open up the tool. You're going to use the buttons to create the statement below, which is basically the dsm.tif minus the dem.tif. Then I'm going to suggest you call your output raster height model. Now that we've downloaded the DEM and the DSM, we need to extract it into our project folder. So in order to do that, we're going to right-click on the file. We're going to say extract all, and we're going to browse to our location of our project file. And I'm going to select the folder. I'm going to choose extract. I'm going to do the same thing with the DSM. Okay, I did that to the wrong location, so I'm going to try that again. Delete that and extract all. And this time I'm going to make sure I browse to the correct location, which is my Halifax Trees project folder, and then choose extract. Once they're extracted, I can add it into our new project. So to do that, we're going to go to our Map tab, Add Data, and we're going to go into our folders, Halifax Trees. We're going to hit the refresh button because it doesn't do a good job refreshing. And you can see here's our DEM and DSM. So I'm going to select both of them by holding my Control key down and hit OK. So you can see here I have my two layers, the DEM here on top and the DSM underneath. So now I'm going to remove or subtract the DEM from the DSM. So again, to do that, we're going to our Analysis tab, Tools, and then we're going to type in raster calculator. I'm going to click on the Spatial Analyst one. And then we're going to open the window up a little bit more. We're going to take the DSM, so I'm going to double click on it, and you can see it appears in the box below, minus, and it'll be the DEM. Okay, and I'm going to give it a name, and I'm going to suggest you call it height model, no spaces. Okay, oops. And then I'm going to hit the run button down here. So what that essentially is doing is giving us the actual height of individual items within our map. So you can see here is what it looks like. And now I am ready to apply those heights to my tree points. Once we have the height model for our part of the city, we need to attach those heights to the tree points. To do this, we're going to go to the Analysis tab, Tools button, and in the search, you're going to type Extract Values. You're going to select the Extract Values to Points Spatial Analyst tools. In the tool itself, the input features should be Studley trees. The input raster will be the height model you just created. And your output point features is going to be Studley trees with height. So we're going to create a new point file that contains the height of the trees. How do you apply these elevations from our height model to the points? Well, we're going to go to our Analysis tab, Tools, and the tool this time we're looking for, we're going to start typing in Extract Values, 2 points, okay, so it's a Spatial Analyst tool. The point feature here is our Studley trees. Our input raster is the height model that we just created. And I'm suggesting you call this Studley trees with height. Okay, and then we're going to hit the run button down here at the bottom. It'll take a moment or two. And you can take a look at the attribute table just so you can see what's happened. If you open the attribute table and we scroll to the end, you'll notice there's a raster value that has been added. So that's what came from this height model. Next, we're going to prepare our tree data for symbolization. It's important to realize that not all trees are symbolized in 3D in ArcGIS. As such, we need to make some decisions on how the trees that are not currently symbolized should be shown. So, for example, not all maple trees are in the symbolized tree list. Likely picking a different type of maple on the list will be close enough for this visualization purpose. So, in order to make sure that we don't alter our original data, we're going to create a new field. So to do this, you're going to open the attribute table for the Studley trees with height. You're going to click on the Add button, and you're going to add a field name that's called a displayed tree with a data type of text. Save the edits and return to the attribute table. Because our database for our 3D trees doesn't contain all the trees, what we're going to do is we're going to create a new field called display trees, and therefore we'll adjust that layer accordingly from our data. So how do you do that? You're going to make sure your attribute table is open. You can see mine is open down here. If yours isn't opened, then what you would do is you would right click on the name of your file and you choose attribute table, but mine's already open. So I'm going to just bring the window open a little bit. We're going to click on the Add button. We're going to scroll down to the bottom and we're going to create a layer called Display Tree. And we're going to give it an alias called Display Tree with a space. And we're going to make it of type text. And then we're going to click the Save button up here at the top. Okay, when it's finished, you can close out. And if you scroll to the end, you'll notice there's now a new display tree field. Next, we're going to go and download a Word document that contains a Python script so we can populate our new field that we just added. So go to https://dal-spatial.arcgis.com/sharing/rest/content/items/6C9DAE 872020476 DAC 3210A 9490979A9/data. Download the file there. Put that file into our project folder. Again, it's good practice to keep everything together. And then you're going to open the file and copy the contents out of it. Now we're going to download the script to help populate this display tree field. To do that, you're going to open up your browser of choice. I'm going to start a new tab and then go to the link that I gave you. So by default, mine automatically downloads my file. You can see it's this display trees doc. Okay, so I'm going to go into that folder. There it is, and I'm going to move it into my project folder. So I'm going to use a Control-X on my keyboard, and then I'm going to go into my project folder and paste it there. Okay, and you can see there it is. Once it's there, I'm going to open it up. So I'm going to double click on it, and it's going to open it up in Word. So you can see there it is. I'm going to enable the editing. And I'm going to copy everything in this file. So this is a Python script, and we'll spend a little time looking at it momentarily. So I'm going to go and select it all, use Control-C on my keyboard, and then I'm going to minimize my window. Take a look at the code that's supplied. You'll notice the variable called unknown_tree_name. This is the type of tree that will be entered if the rest of the script is unable to figure out what should go in there. The available trees attribute is the list of the plants and trees that are available in the rule package for displaying 3D that we're going to be using. The mapping table, this is a dictionary listing that's used the general names of the plant or tree followed by the colon and then the type of tree that will be entered. So the script is actually going to take a look at the last word of our plant type and use that to try to figure out what type of tree it is. Okay, and this mapping table will allow it to pick the type of tree based on that last word. Okay, and the type of tree that it's going to display must be from the available trees list above. Now we're ready to populate the new display tree field. To do this, we're going to make sure the attribute table is opened. Right-click on Display Tree Field Name. It's going to bring up a pop-up. Choose the Calculate Field option. You're going to make sure the expression type is Python 3 because the script we copied is a Python script. In the code block, paste the Word document that you copied, so that's that tree display type from the Word document. In the field box, you're going to double click on Common Tree Type, okay, from the list above, and then before the Common Tree Type, you're going to type in to_new_tree_type and an open bracket because that's the name of the script we're going to run that's below. At the end of the common tree type, put a closing bracket. Now that we have this text copied, we're going to close out of it. We're going to make sure our file is open. Under Display Trees here in our attribute table, we're going to right-click and choose Calculate Field. It's going to bring up a pop-up, and we're going to make sure our expression type is Python 3 because the script is a Python script. And in the code block, I'm going to paste in the file that I had mentioned. Okay, so again, remember, this unknown tree type will be what happens or what tree type gets classified as if we don't know what sort of tree happens based on the rest of the script. These are the type of trees or plants that are available for display in 3D. Okay, and if you scroll down, our mapping table is what happens if the last word of our tree name is of a certain type. This is the tree that gets displayed. This display name must be from this list above. Okay, and down here, this is the name of our script, and that's what we're going to be calling. Okay, so we're going to go up here to our common tree type. I'm going to double click on it, and then just immediately before that, I'm going to type in to_new_tree_type. I'm going to open bracket, and then I'm going to put a close bracket at the end. And then I'm going to click the OK button down here. Take a moment or two, and our display trees, if you scroll to the end, is now populated based on one of the trees that are in our display type. If desired, you can change any of the values in the display tree field. It can be done manually by clicking into the attribute table and adjusting the value, or by selecting features by attribute and using the field calculator button. Just remember, you will need to make sure the display tree name is one of the options that are available. You can take a look at that in our script. If you do make any edits, please make sure you save your edits. If I want to make any changes to this display tree type here, I can certainly do that. So what I'm going to do is I'm going to right click here so I can see what options are here. I'm going to sort ascending. So I'm going to scroll down to where it's generic, our generic trees. So again, this is an alphabetical So this is a generic unknown. So if I actually wanted to change the value, I could kind of select in here and type in my value. Or conversely, I could do select by attribute using this common tree field. Okay, if I make changes, make sure you go up to the edit table and choose the save option. I'm not going to make any changes at this case, but it's important to know that you can. Next, we need to convert our 2D map into a 3D scene. So in order to prep for this, I'd like to remove all of the layers except for the studly trees with height from the Contents panel. Then, in the View tab, click on the Convert button, and you'd like to convert it to a local scene. In the Content panel, you're going to drag the studly trees with height from the 2D layers to the 3D layers. To prep this from going to a 2D map to 3D, I'm going to remove all of my layers here. So you can see I'm just selecting on them and clicking the Remove option. Again, we don't need the standalone table either, so I can take that out. I'm going to leave the base map in here. Okay. From here, I'm going to actually close out of my attribute table. I'm going to go to the View tab up here at the top, and I'm going to click on this Convert option, and I'm going to convert to a local scene. Okay. I'm going to click on that. It'll take a moment or two to convert. And you'll notice now I have a map 3D up here. Okay. When it finishes drawing, then what we're going to do is we're going to move this studly trees with height from the 2D layer into the 3D layer. Okay, so you can see it's trying to draw down here. You can see the wheels turning. But I'm going to, in the meantime, just drag this up from the 2D to the 3D layer. Okay, and once it's in the 3D layer and you have a scene, you'll now be able to move your screen around using your mouse. Okay, if you don't know how to move your mouse, you can go to the Map tab and use this Explore button. If you hover over it, it should give you some information about how to use it. Okay, so again, here are my points, and if I hover over it, it tells you kind of how the screen moves. Okay, so again, I'm going to see there, and now I have my trees. Next, we're going to download the rule package for symbolization. To do this, you're going to go back to your browser and you're going to go to https://www.arcgis.com/home/item.html ? ID equals DCC93E 3D9BF 744999783 BEDFCD 7E4BA2. Or probably a lot easier would be just to do a search for ArcGIS plant_loader_points. From there, download the file plant loader points and put it into our Halifax Trees project folder. Now we're going to go to our browser of choice again, and in our window we're going to do a search for ArcGIS plant_loader_points, and I'm going to hit enter. It's a lot easier than typing in that long name I gave you. I'm going to select the plant loader points overview file, and then I'm going to click on the download page. It'll take a bit to download. It is quite large, but when it finishes downloading, you're going to download it, take the downloaded file and put it into our project folder. So you can see it's very slow here, so it will take some time. It did take a little bit to download, but when it finished, we can go into our downloads folder, and you can see here is our rule package. I'm going to put this into our project folder. I'm going to cut it out, and then I'm going to go to my project folder. Okay, and I'm going to paste it in here. And I'm good to go for our next step. Now we're ready to apply the rule package to symbolize our trees. To do this, you're going to right-click on Studley Trees with Height in your Contents panel and choose the Symbology option in the pop-up. In the Symbology pane on the right-hand side, click on the symbol. Click on the Layers icon and then use the drop-down to change to Procedural Marker. Click on the Rule button and select the Plant Loader points.rpk that you downloaded and moved into your project folder. Now we're ready to use the rule package to symbolize our trees. So how do we start? We're going to right-click on Studley Trees with Heights. We're going to go to our Symbology option. In our Symbology panel, we're going to click on our Symbol button. We're going to go to the Properties tab up here at the top, and we're going to make sure that we are on the Layers button, which is this second button that looks like the stacked pieces of paper. We're going to change it from Shape Marker to Procedural Marker. Okay, it'll take a moment, and then you'll notice this Rule button appears. You're going to click on the Rule button and select the rule package that we just added. So again, this is in my folders, and you can click on your folder and find your file. So it's the plant loader _points.rule package. You're going to click OK. Okay, now we need to adjust the fields based on the parameters as required by clicking on the attribute driven property. That's the icon that looks a bit like a can. So for the name, click on the can and choose the display tree field. For the height parameter, choose raster value. So that is the one that had the height of the trees in it. For the random height, change it to mature only from the drop down. Click the apply button and take a look at what you have. Now we're ready to populate our attributes. So you can see by default there are a number of defaults that are automatically set. If you want to use your attributes, you're going to click on this can icon, which is your attribute driven properties over here. So we're going to adjust the name. We don't want it to be orange tree. We want it to actually be our new field that we added called display tree. Okay, then we're going to click the OK button. You'll notice that the icon changes color and we lose the plus sign. For the height, again, we're going to use the height that in the field that we created. So again, we're going to click on this can icon and we're going to use the raster value. So that was the height we derived from the LiDAR. And we're going to click OK. Again, you'll notice these two icons have changed. The other thing that I'd like to do is where it says the random heights here, adjust it to mature only. So basically we want to pull the heights from here. We don't want it to start adjusting the heights on its own. When you're finished, you're going to click the apply button here at the bottom and take a look at your data. It'll take a moment or two to apply, but ultimately your trees will start to appear on your screen. Congrats, you've done it. Explore your data. Use your mouse to look around at the data. If you're unfamiliar with moving around in 3D, it will take a little bit of practice. If you click on the Map tab and hover over the Explore button, you'll get a quick explanation for how to move around. So now pan around your data and take a look at what you have. So again, using the center ruler button, you can zoom in. If you want to change perspective, I'm clicking down on my center button and take a look at the data that you have. Enjoy and congratulations. I hope you've enjoyed this quick tip, or I guess quickish tip. If you have any questions or would like to talk to us in the GIS Center, we're located on the 5th floor next to Special Collections in the Killam Library. My name is Jennifer Strang. I can be reached by email at jennifer.strang@dal.ca, or you can give me a call at 902-494-1386, or you can book an appointment with any of us at the center online at www.dal.ca/GIS and click the Book an Appointment link. Thanks.